Hey y'all, hello, it's Liz, and I'm doing the virtual demo for Virtual Demo Day, and I'm not sure that I really got how this is supposed to flow, but I'm going to give it a try. So this is just a presentation that I've narrated. I don't know if I'm going to be showing this to you, or I'm going to be talking to you personally about it, but we're just going to be looking at data this summer, data, however you want to pronounce it, as it relates to epidemiology. And one of the points I want to drive home with the students is, yeah, we're going to be looking at math, but to know and realize that epidemiologists are not statisticians. They do rely on good data, so they do need that information from a statistician, and epidemiologists know how to crunch numbers a tad bit, but their main role would be data interpretation. So are they getting it from good academic resources? Can they draw conclusions, interpret that information, and make connections? That's their big thing. So the students are going to be a little bit like an epidemiologist, I guess, and they're going to be looking at data, and they're going to look for patterns and really see, what does this information tell us about who got sick from a disease, what was the disease, when did they get it, what locations did it affect, etc. So really, what is the data telling us about that disease and how it's being spread, and can we prevent it from spreading in the future? And so that's kind of the gist of the math module, statistics module this summer. So they're going to be getting data from various resources, like looking at maps. Can they extrapolate enough of that information to come up with some solutions, or even make a prediction about what might happen with that specific disease in terms of current and future aspects? So the math is going to be pretty basic. They're just really looking for patterns from those resources. So it's a lot of graph interpretation, and we might do a little bit about how quickly cells grow, a little bit of that. And also they're going to look a little deeper too in terms of, is that information telling us about disease, but is it also pointing to obvious or even hidden inequities? So there's a lot of things that might stick out, and a lot of things we might have to dig deeper for. We'll also do a little basic information about pathogens themselves, so disease-causing agents, and really, what is an epidemic? Community versus global pandemic. How are things passed along? What are vectors? How severe is the disease? Is it going to make you a little bit sick? Is it going to make you a lot of sick? How does it get into your body? What's the portal of entry? What's the incidence of that disease per season, and what's the difference between that and prevalence? In terms of portal of entry, we might talk about contact. We might talk about the vehicle of the disease. In other words, are you getting it from food that's contaminated, or water that's contaminated, or did someone sneeze and it got passed in the air? And then we'll talk about samples, why we take them, and then how we can take them. And I think students know a little bit about this. When I have on there, I mentioned using chemical tests, etc. The students won't really get to do a series of those this summer, but they will at least be able to do some plate collection, where they'll do more of an environmental study. So we will send them home with plates that have media, really basic media, and they're going to attempt to grow some of their own cooties or germs just by swabbing household objects. If they want to swab something outside, if they want to swab their laptop, their phone, the back of a chair, just determine what might be out there. And I think bring it into a different view by growing it on the plate. So they're going to take those samples, they're going to grow some stuff on their plates. It may take a day or two, or maybe 3, considering they won't be in the lab. And then we're going to look at that growth. So they're going to label their plates, take the sample, and then use a handheld magnifier to look at it, because they won't be in the lab. And so we're going to observe just basic characteristics. So the students might just look for texture, color. Is their sample, does it look smooth and slimy? Does it kind of look fuzzy, like maybe it's a mold, or it's some kind of yeast or something? And so they can look at basic characteristics and draw some conclusions. But when I grow in the lab, it'll be a little bit more controlled. And so while they use their hand magnifiers, I'm actually going to use a colony counter. And that's when we'll do that little streaming session like the dissection group is doing. We'll do ours in the lab, where the students will have their hand magnifiers and try to get a more in-depth look. And then I'll plop mine onto the colony counter, where that's an image of it right there, where it's like a grid. And I'll try to give a guesstimation of colonies. So when you all see those little dots on there, that's not 1 or 2 or 3, but it's hundreds of thousands and millions of bacteria coming together to form that dot or that colony. So they'll do that little experience, and hopefully it won't gross them out too much. And then we'll also do the scenario and then the mock epidemic, where they look at some data, background information, a specific disease, and they'll make some decisions. Now, this is kind of like we've done in past summers, where students take on a role. Maybe they're a doctor, an anti-vaxxer, a concerned activist, a parent, a teacher, a nurse, etc. And they take their specific perspective to look at that disease. And just like previous summers, we're going to bring it back to the collective, and everybody will kind of present their case and we'll solve it. It won't really be like the debate, but we will be sharing it, doing a little resolution and Q&A. And maybe some of the students will even change their mind. So we'll bring it back for that question and answer. We'll do a little analysis, and students will learn about the different perspectives and the approaches that other students experienced. So the whole rigmarole for that scenario, and then also the mock epidemic, is you have to think who got invited. What was the germ? What was the disease? Who was the host? Who harbored it? And what disease was the guest? And was it invited or uninvited? And how did we find out it was around? Who ratted them out? Now, the students are also going to talk about zoonotic diseases a little bit, or things that we kind of have around us, but also we know with COVID-19, with the global issues, that was a zoonotic disease at the cause of that. So we'll be epidemiological detectives again. They'll go out and they will look maybe in their backyard or front yard, on their porch, outside their window, wherever, and they'll collect some data. So they won't physically do it, but they're going to find some examples of some of those possible agents of disease, like mosquitoes or flies, things that you see in your house sometimes. Maybe they've got a little bit of soil in their backyard and it looks a little funky. Maybe there's some mold growing on it. Maybe they see some animals outside in the yard that might have fleas on them. Maybe they live in an apartment complex and there's somebody who's walking their cat, or maybe they walking their dog and they see somebody's pet pooping. Okay, so all these things that are vectors of spreading disease. So this summer we'll be introducing concepts, forming ideas, doing a scenario, a mock epidemic, being a field epi-PI, and growing plates. And that'll be it for the Math Stats module.